everyone. Speaking with us today is Dr. Ritendra Datta, Director of Engineering at Meta, who completed his PhD degree from Penn State. Dr. Datta, would you like to tell us a bit more about your background and research?
Yeah, definitely. So I studied grad school at Penn State. I spent 5 years doing a PhD in computer science. My area of research was machine learning, computer vision, a little bit of information retrieval. All of these are, I don't know, like it's been more than a decade since I did my PhD, and all of those topics are still super relevant. After I graduated PhD, I went to work at Google. Initially, I was in the Pittsburgh, Pennsylvania office. Then I moved to the Mountain View, California office. Then at some point in time, I spent a decade at Google and decided, yeah, I've had enough of Google. I wanted to see what else is out there. And then I joined Meta. At that time, it was called Facebook Inc. Now it's called, last year it got renamed to Meta Platforms Inc. Ultimately, the work is still the same. We work on Facebook, Instagram, WhatsApp, and virtual reality, augmented reality, that sort of stuff. So I'm particularly focused on the Facebook experience. Facebook is still extremely popular worldwide with, close to 3 billion people using it every month. There's like a little less than half of the world's population, so it's a huge responsibility to keep the service going and making sure that it's interesting and exciting. I run specifically the team that does video recommendations, which means videos also include reels, which are these short form vertical videos. Historically, we worked on long form horizontal videos for the most part, sometimes square videos and so on. But the format of the flavor of videos that is the most popular right now is short form, like less than 90 seconds, vertical videos, which means you can hold your phone vertically and then still enjoy the content. So my team uses machine learning and information retrieval to recommend all sorts of videos and reels to our 3 billion users. So it's a pretty fascinating area and lots of open-ended problems in that space, because recommendations in general doesn't have a right answer. I could show someone something different and they'll still enjoy the same stuff. But then sometimes if you have an exam, there is a right answer. Okay, 2 plus 2 is 4. Or even in things like when you're trying to predict if somebody is emailing spam to you versus a legit email, that classification there is a right answer. Certain emails are spam, certain emails are not. So artificial intelligence and machine learning, when they solve those types of problems, there is a ground truth, as we call it. Like, this is the reality and you're trying to predict that well. But with recommendation systems, be it for Facebook or YouTube or Netflix, there is no right answer to recommendations. So that is what makes my area of work quite researchy and quite interesting and quite open-ended, and I think we'll continue to improve these systems over the next decade.
Thank you so much, Dr. Datta. I think we can move on to the Q&A then. My first question for you is, what sparked your interest in machine learning and statistical modeling?
Yeah, I mean, when I was a kid, I was doing computer graphics programming because that was like the coolest thing to do. Because when you write, I started writing code and I was lucky enough to have a computer and started writing code when I was, I think like 10 or 11 years old. And then I found that I was in middle school and high school, my popularity was a function of how cool of a computer graphics program I could write. And so that sort of gave me motivation to write more computer graphics programs. I wrote a bunch of very interesting computer applications. Like I wrote a chess program. I think I wrote an early version of sort of Google Maps for a city in India before Google Maps was a thing. So I dabbled with a lot of that stuff. And then when I came to grad school, I realized that, yeah, all that's fine and it's cool and it's fun to, get a lot of appreciation from friends and and parents and so on. But really what I figured out was that the world is moving toward higher volumes of data. Every system out there is collecting so much data that making sense of that data is going to be the problem of the next 3 decades. And so I actually switched from just doing cool programming because it made me popular with my friends to what I felt was the most important problem to solve. And so I switched from computer graphics and some other areas that I initially thought I'd work on to statistical modeling and machine learning, because ultimately being able to make sense and to be able to predict the future using data is going to be a very compelling theme. And I sort of was lucky enough to figure that out 15 years back, and like 15 years forward, I mean, we are still trying to figure that out. We are still dealing with huge volumes of data. We are still collecting more and more data with 1 billion sensors. If you think about the number of security cameras out there, just the amount of data that they're collecting, trying to figure out like what's problematic is like finding a needle in a haystack, and humans could not possibly figure that out even with like large dedicated security teams. Like just one example of a problem where huge volumes of data just keeps growing in magnitude, but there's not enough people to process them. So you still need machines to make sense of data that we're collecting, like even the social networks, this video call, the conversations we have via private chat messages and groups, and the videos we watch. Again, I mean, coming back to my area of current expertise, the videos you watch on Instagram and TikTok, the messages you send on Snap, all of that stuff is just like data that's accumulating. More and more people are using it, but we don't have enough manpower to like really process all of that and make sense of it. So I sort of saw it where it was 100x smaller. But fast forward 15 years from when I started my PhD, like to now when I've been in the industry for a few years, I continue to see the need for statistical modeling and machine learning and data analytics and all of that. And that's why we run large teams of engineers and scientists working on that stuff. Just one background. Right now, I run a team of almost 200 engineers and research scientists at Meta. So there's a lot of work that we do along many of those dimensions. And the reality is like machine learning is a cool, interesting area, but like we sit on top of many other layers of technical work that we do. Some of which are like pure infrastructure design, like software infrastructure is a very cool area that without which like all this the cool stuff is impossible to do, because you rely on that infrastructure.
Thanks. The next question we have for you today is, what challenges did you face when working on the recommendation system for Meta and various other companies? Can you tell us a bit about the challenges?
Yeah, I don't want to speak specifically for my current company, but I think in general, I understand this industry pretty well. I worked at Google as well before. Across the board, these problems of I used to work on search at Google and recommendations at Meta, and across the board, there are some common themes that arise when you work on these problems, right? So the biggest one is how do you sort of make services better and more useful without being intrusive? Like the reality is, the people that know you best can recommend stuff to you, can help you get whatever you're searching for. If you had a human being that was like a parent or a sibling who spends so much time with you, know exactly what to recommend to you, or know exactly like when you search for something, what you really mean when you search for that. Now, the interesting thing is, like, but there are only a small number of people that you're comfortable knowing you that well. The problem is now we are in this world where we're sort of fighting between knowing people intimately and recommending or giving them good search results versus maintaining your privacy and your independence and your ability to like filter out everything that the systems know about you and just give you unfiltered stuff, right? So like there's this whole battle between knowing more about you and giving you relevant information, and knowing too much about you and you losing privacy and your personal space in the process. So I think the challenge is like, what is that sweet spot between like recommending or giving search results that are highly relevant and like maintaining people's privacy and making sure that data that is used to get better at recommendation is safe with you, and you make sure that you don't sort of cross lines that make you uncomfortable, right? So to me, both search and recommendations have that problem. The more you know, the better you get, but you start to become uncomfortable at some point with how good they are at knowing you. Then you're like, is it safe? Are we comfortable? Users start to tell us that, hey, this is too much. So what is that line where you stop becoming useful and start becoming creepy is a very interesting line. And so those tend to be some of the hardest problems, right? The other big one is, I think like people don't necessarily want to be reinforcing what they already like. So for example, if you really like tennis and we keep serving you content that's tennis related, at some point I will be like, I want to try something different. Why are you just telling me the same thing? How do you diversify? How do you sort of have a fair process of recommending stuff? How do you have a fair way of serving up search results such that it does not like reinforce any stereotypes or serve up the same stuff and influence you in a way that you don't like, that you become uncomfortable? Like those are the really hard problems. Like I don't think anyone in the industry has solved these problems, which is why they remain challenges in this field across the whole spectrum of companies. I know people in all these industries. Like Amazon has its own ad system. Like when you search for a product on Amazon, you get a lot of recommended, like promoted search results, right? The question is only recommending stuff that is appropriate for your economic background. It starts to assume that you are you're capable of only purchasing certain things, and it'll not show you things that you might aspire to buy when you have more money. So then that creates a bias in that system, because it's trying to like do you service but ends up doing disservice, because it's starting to assume things about your economic background that no longer makes you comfortable about using those services. So some of those challenges, if I were to summarize that in one or two words, is to be, how do you build a fair, friendly and yet useful search and recommendation systems? Those are sort of the grand challenges of our industry, because nobody has solved it and everyone's trying to like figure out what's the right answer. And the interesting thing is, even that question that I ask matters to some people and doesn't matter to others. Some people are like, I'm totally fine with this. Other people are like, I'm super uncomfortable with systems knowing. So even like the degree to which you're comfortable with these things varies with individuals. So it makes the problem where we are building one set of algorithms to solve all these problems super hard. We don't even know like who wants what, but we still, when we remove these kinds of when we remove personalization, we always observe that the services are less useful. So if you just had everything generic, if Google search was always serving the same exact results, even knowing that when you say something like ball game, are you talking about soccer? Are you talking about baseball? Are you talking about football? Are you talking about cricket? Like all of those things, you would benefit from Google knowing more about what kind of ball game are you talking about. But then like that starts to bring in those biases into these systems, because then you're like, I'm trapped. I'm only seeing cricket. I want to like know more about baseball. How do I do that, right? So that's the whole industry is challenged by these problems.
The final question we have is, how can high schoolers get involved with machine learning?
That's a fantastic question, and I would love for that to happen. I think, as I said, machine learning is turning out to be one of those like areas of computer science, mathematics, and statistics that is going to be here to stay, and the innovation is going to continue because we're only scratching the surface of what these systems can do. So I do think, and this is why I'm saying this, because if the field is not super exciting, I don't think high schoolers should get involved, because by the time they're in the industry, maybe it's not that relevant. But that's not the case with machine learning. With machine learning, I think high schoolers getting involved means that 6-7 years down the line, when they're in their second job or whatever, or first job or second job, their skills in machine learning will be highly valued, right? I think the good thing is there are a really large number of open source toolkits that are available and open source data sets that are available. So basically, machine learning, the simplest way to describe this is you have a public domain data set, you have an open source software tool, you just take that data set, you plug it into this software that trains a model and does some predictions, you see the outcome of those results, right? So if you have a computer, if you have like a Mac or a Windows machine, it should be trivial to get started, right? So I think it's a matter of like a couple of days, really, to have your first model trained. That doesn't mean that you'll understand how things work. It's mostly the what part that you can figure out in a couple of days. Okay, here's a toolkit. Here is a data set. Here is a step-by-step way to get it. That will take a couple of days. Now, I think the next step would be sort of work backward from there to figure out, okay, how did it really work? That's going to take more time. One thing that I would encourage is, if you're interested in machine learning, to brush up on your mathematics and your probability and statistics and your linear algebra. If you have linear algebra classes in high school, that's great. If you don't, you'll probably do them in college. It's fine to like not understand everything right now, because the mathematics behind a lot of machine learning is quite advanced. So it's fine to initially gauge your interest by just doing, like using pre-existing tools, so that you can just see the outcome, like you see the magic. Hey, a classic example is, you give me the location and you give me the the time of day, and I'll predict the temperature tomorrow. Like if you have a historical data set on weather, you can actually build such a model. And it's fascinating to show that to someone and say, hey, look, I've built this very simple thing that can predict, and it's pretty powerful. That itself will be the first step for high schoolers, because now you're like, okay, I have an end-to-end thing that works, and I can show it off to family and friends and all that. And that feedback is really important, because I think it's very hard to maintain attention these days. There's so many sources of distraction that the biggest way to keep engaged in a field like machine learning is to get that feedback, that positive reinforcement from friends and family. Hey, oh, you're doing something cool. This is good. So playing with the toolkit in a way that's quite similar to, like, I think there are a bunch of like high school robotics classes and things like that is easy to get excited about, because you're actually seeing something move. And this is the equivalent of like what I was earlier saying about graphics, right? Graphics has this instant gratification, as I would say. Like you write some code and suddenly something's happening on screen. You want the equivalent of something like that for machine learning by using these toolkits and taking a problem that people think is important around you. Oh, predicting the weather is important. Like maybe you're doing it just for your own backyard at your home, right? So that's super hyper specialized. So you're building something for your home. So someone else is not building it. So you're the only one in the world who's building a predictive weather prediction system for your home. So that piques your interest. Your friends and family encourage you to do more. And then that's where the next step happens, where you start to like understand how it works. Is this really magic, or is there some very simple explanation for why it works? So I would work backward from getting something end to end running, showing it to people, making sure you get enough of that like encouragement from people around you, and then you sort of work backwards, and then you can decide to stop. Like the interesting thing about machine learning is that you don't have to be a math expert to be a really good machine learning practitioner. So you can choose where to stop, right? You can be a researcher who's like doing all the math themselves and changing it, or you could just be a practitioner that is just building these systems that are really, really useful. And I think it's totally fine for different high schoolers to aspire to end at different points. So I think that's how I would say. And I think the other thing outside of open source and publicly available data sets is to be able to work with companies. If you have opportunities to work at companies like Google, because some of these do have like some STEM programs that do teach you. I don't remember. I think it's a summer of code, and I guess there are some other things that are either for high schools or college students. So I think like getting exposure through industry programs is another way to do it. And I don't have a list of those off the top of my head, but I think you can like Google these and easily find out. I think there is definitely an interest in the industry to get the next generation of American high schoolers to be learning this, so that America is self-sufficient with respect to the talent that it needs. Otherwise, it's amazing, like the percentage of people doing machine learning that are not born in the US but working in the US is extremely high, which suggests that there's not enough Americans that have that skill set right now. So I think that's where like the next generation of high school students can sort of bridge that gap, so that there's plenty of talent within the country to meet the needs. So.
Yeah, well, everyone, thank you so much for watching my interview with Dr. Datta. Take care, and we'll see you all next time.